We're going to be looking at polygons today, lesson 12.3. So to understand polygons, first of all, we need to understand a couple of the major terms. First of all, we have a curve. So a curve, it says in your book, is a continuous set of points. So this right here would be a curve. This would not be a curve, because notice there are breaks in the set of points. So these would be several different curves. Next, we have simple. Simple just means the lines don't cross. So this would not be simple because notice right there the lines are crossing. This would be simple because the lines never cross. If you have any point where the lines intersect, they cross, that's not simple. If they never cross, it is simple. Closed means wherever it starts, it ends up. It starts here, it ends up here. That's not closed. This would be closed. So a polygon has to be simple so the lines can't cross. It has to be closed, so wherever it starts, it has to end up. It has to be made of line segments, so it cannot have a curve like this. There are two types of polygons. There are convex and concave. Concave means it has a cave. Convex means it doesn't. So both of these would be concave because they have an indentation. I know that because if I draw any 2 points and I connect them, notice how the line goes outside. Same thing here, when I connect them with 2 points, line goes outside. Here I could put any 2 points and they would never, ever, the line would never go outside. So that is convex. We have sides and then we have vertices. So one vertex we call a vertex. It's just where 2 sides meet. The number of sides will always be the same as the number of vertices. So if I have 4 sides, I have 4 vertices. If I have 5 sides, I have 5 vertices. A regular polygon means all of the sides and all of the angles are equal. So for example, in this figure, I can see they are equal. This is a 1, 2, 3, 4, 5, 6 is a hexagon. They're all equal because they all have those dash marks. That means they're equal. And then the angles are all equal because they all have the same little semicircle there. This right here would not be regular because all of the sides are not equal. This side is bigger than this side, so it's not regular. Regular, all the sides and all the angles are equal. We have a lot of different polygons. The smallest possible polygon I can have has 3 sides. It's a triangle. 4 sides would be a quadrilateral. 5 sides pentagon. You can read the rest in your book on page 500. Make sure you know those. Let's look at the triangle first. In a triangle, all of the angles in a triangle add up to 180. That's really helpful because if I know 2 of the angles in the triangle, I can figure out the last one. So let's say I have this triangle right here. I know this is 50, and I know this is 100. Well, what's the last one? Well, they all have to add up to 180. 100 plus 150 is 150. So I just do 180 minus 150 to get my last angle is 30. So if I know 2 angles in the triangle, add them together, subtract from 180, and that will give me my last angle. There are 2 ways to classify triangles. I can classify them by their sides. If no sides are the same, we call that scalene. So if every side is different, that's scalene. If at least 2 sides are congruent, that is isosceles. So isosceles means at least 2. If all 3, that's also isosceles, but we call it a special name. We say it's equilateral if all 3. So equilateral is really a type of isosceles. Angles, we can classify them by angles. So we either classify them by how many sides are the same, or we classify them by their angles. Those are 2 different ways. So if it's all the angles are acute, that's an acute triangle. If just one angle is right, it's a right triangle. And if just one angle is obtuse, it's an obtuse triangle. So acute, all of them have to be acute, but right, only one has to be right. In fact, you cannot have a triangle with more than one right angle because that would mean you have 2 angles would mean 180 and then you wouldn't have a third angle. Same thing with obtuse, only one has to be obtuse. Let's look at a specific type of polygon, the quadrilateral. So quadrilateral member means it has 4 sides. There is a special type of quadrilateral called the trapezoid. A trapezoid has at least 1 pair of parallel sides. So this side and this side are parallel, they will never cross. These are not. A parallelogram is a type of trapezoid. It means both pairs of sides are parallel. There are 2 types of parallelograms. If I have both sides are parallel and all the angles are 90 degrees, that's a rectangle. Another type of parallelogram is when all of the sides are congruent. That's a rhombus. If something is both a rhombus, all the sides are congruent, and a rectangle, all the angles are 90, then it is a square. So a square is everything that's in this line. A square is a rhombus, it's a rectangle, it's a parallelogram, it's a trapezoid, it's a quadrilateral, and it's a polygon. A rectangle is everything except those. So a rectangle is a parallelogram, a trapezoid, a quadrilateral, and a polygon. Same thing with a rhombus, it's all of these. A parallelogram is everything that's above it. So the things that are below are included in everything that is above. Finally, if I have a quadrilateral, if I take one vertex, let's just take this one, you could choose any one, and I draw a line from that vertex to another vertex that's not adjacent. This vertex and this vertex are next to it, so those are adjacent. So I draw it to this vertex over here, we call that a diagonal. Let me give you another example. Let's say I have a hexagon. So a hexagon, this would be, if I can choose any vertex, I'll choose this one. These are the adjacent, so I can draw it to that one, and that one. So the diagonals go from one vertex to any other vertex that is not next to it. So if I want to know how many diagonals I can draw from one side, I simply take the number of sides and subtract 3. So quadrilateral can only have one diagonal from this side. Hexagon, 6 minus 3, can have 3 diagonals. Now, if I want to know how many diagonals it can have total, then I have to draw from all sides. So from this one, I could also draw from here to here. From this one, I've already drawn that. So a quadrilateral could have 2 total, and so on. How about if I want to know how many, what the angles add up to? Well, notice when I drew my diagonal, I actually divided it into two triangles. Each triangle adds up to 180. So every diagonal that I draw from one vertex divides it into a triangle. This one divided into 1, 2, 3, 4 triangles. Again, since I know each triangle is 180, I just multiply by how many triangles I have times 180. The easiest thing is to use this formula. The number of sides you have minus 2 times 180. So if I have 4 sides and I want the sum of all the interior angles, I do 4 minus 2 is 2 times 180, 360. If I have a hexagon that's 6 sides, I would do 6 minus 2 is 4, and then multiply 4 times 180 to get the sum of the angles. What if I have a regular polygon and I just want one of the angles? Remember, regular, all the angles are equal. So once I get the sum by using this formula, I just divide by how many angles I have. The number of angles is the same as the number of sides. So after I get the sum, if I just want one, if it's regular, I divide by how many sides it has. So just a couple of things in your lesson to make sure you understand. So in the first section of your lesson, you're saying whether or not they're simple. Remember, simple means if they cross, they're simple. If they don't cross, they're not simple. Then you have whether or not they're polygons. Remember, if they're a polygon, they have to be simple. They can't cross. They have to be made up of line segments, so there can't be any curves. And they have to be closed. If it's concave, that means it has an indentation in it. If it's convex, it doesn't have an indentation. Regular means all of the sides are the same length and all the angles. Just be careful for numbers 8, 9, and 10. You're classifying it by the sides, so it should be one of these 3. For numbers 10, for 11, 12, and 13, you classify it by the angles, so it should be one of these 3. For 14 and 15, when you're drawing, make sure you show which sides are congruent by drawing the lines like I did here. So if it's a scalene, none of the sides should be congruent. If it's isosceles, you should have those 2 sides being congruent and showing that, and so on. For numbers 22 through 24, you're doing the sum of the measurements. So you're doing the number of sides minus 2 times 180. Make sure you get the label, which is degrees. For 25, 26, and 27, you want each angle of the regular. So first, use this formula to get the sum, and then divide by how many sides it has. And again, the answer will be in degrees for 25 through 27. For 28, 29, and 30, you're finding the number of diagonals from one vertex. That's just the number of sides minus 3. And then you also have to find the total number of diagonals. So you want to actually draw the figure and draw how many diagonals you can do. So you should have two answers for numbers 28 through 30. 31 and 32, you're going to find the sum of the angles using this formula. And then you want to add up all the ones you know and subtract that from the sum to get the missing one. Hopefully that helps and you do well in this lesson.